Welcome to Manifold. Today, we are going to discuss semiconductor technology and U.S. China competition in high technology. My guest is John Y, who lives and works in Taiwan. He has a Substack and a YouTube channel called Asianometry. I discovered Asianometry some time ago because I was trying to track the details of U.S. China tech competition. I was trying to track some of the details that I think we will get into in this discussion. And I found his work extremely useful in understanding things like the deep history of ASML, the competitive situation between TSMC and Samsung and Intel. All kinds of questions that I think strategists, or even people who just want to understand how technology is going to evolve in this era of competition between the US and China, are interested in. So it's a real treat to have John on the podcast. Hello, John. How are you doing?
Doing well, doing well. How about you?
Awesome. So I always like to go into a little bit of background on each of my guests, just because I think the audience likes to kind of understand people's life history. And also my observation is that great minds don't just spring fully formed onto the planet. They are somehow formed through their life experiences. And it's always interesting to get to know what people have done in their lives. So maybe tell me a little bit about your background. I'm guessing you're of ethnic Chinese extraction, but maybe you grew up in the United States. Is that correct?
Yeah, great minds. Wow, now I feel very pressured. I had a pretty ordinary upbringing down in Southern California. After graduating from college in the Bay Area at Berkeley, I worked in Silicon Valley, first in finance, I wrote research reports and valuation reports. And I did that for about 3 years. After that, I kind of got tired of working on so long hours. So I then kind of jumped around Silicon Valley for a while, tried to kind of live that tech startup life, working in kind of how it is with startups. You kind of do all sorts of different things. I wrote code, did data, did marketing. I did a lot of like writing content, stuff like that. And really burned out after that last startup in which I made bras of all things. And from there, I decided that kind of bummed around Silicon Valley for about 8 or 9 months and decided I was going to go to Asia. I sent out applications to companies in 4 different cities: Singapore, Shanghai, Taipei, and Hong Kong. I got offers from all of them. And the only one that gave the best offer was Taipei. So I literally got that offer, thought about it for 2 weeks, accepted, and packed all my stuff, put the rest in storage, and flew out with a bag. And I didn't really expect I'd be here for so long. This was about 5 years ago. Now I'm still here. That's kind of crazy.
Did you have family and friends in Taipei?
No, half of my family is from Taiwan, but they never were in Taipei. They all moved to America just about when I went over to Taiwan. So it's kind of like a funny reversal. My family on the other side is from Hong Kong. So when I touched down here, didn't really have any friends, knew kind of one person, all right, but everyone else, it was just like a clean slate. It was really exciting.
Wow. I almost want to digress and just ask you like what it was like to kind of break into the social circles in Taipei without any base network to start with. That's probably a story all by itself.
Yeah, no, like that's real fun. Like you find out that there's really tight circles here, and there's a lot of stuff going on underneath the surface. I think the harder part is trying to break into the Taiwanese sector, like circles, like the ABCs, ABTs out here they're really close. You actually know, if you know one, you get plugged into all the others, right? So you'll start knowing all the one name and then you hear all the other names and then like find out this name is famous and that name is famous, and it's really funny. But unfortunately, that's not so easy with the Taiwanese people. Yeah.
You know what? I got to hook you up with my cousin, Richard Chang. Now, you're too young to remember Richard Chang. Sorry, I have to digress. Richard Chang is 6'7". He is, as far as I know, the only ABC, American-born Chinese, to receive a Division I college basketball scholarship. Jeremy
Oh my
Lin didn't get
gosh.
one.
Oh my
Richard
gosh.
Chang was a power forward for Cal in the
Wow.
80s. He played at Huntington, I think, Huntington Beach High School down in SoCal. He was a big star on the Cal campus. When I came there as a graduate student, everyone asked me, they couldn't believe it when they heard, like, Richard Chang's your cousin? Because he was so famous. He would just walk around campus and he just stood out, 6'7" Chinese guy. So anyway, he is now the Asia manager. I think he's president of Costco Asia, and he lives in Taipei. So he's older than you, but I should definitely introduce you guys at some point. So,
Oh yeah, I'd love to say hello. Be great.
yeah, that's cool.
Ball.
So go, sorry.
Yeah. So Asianometry started out as kind of YouTube channel for kind of hiking videos. So it was kind of just like the vlog of my life in Taiwan, kind of one of those things that you kind of see around nowadays. But I kind of moved towards kind of long form content because I wanted to make videos that I wanted to watch, especially in content that or in areas that I felt that I didn't really see all that much in kind of the wider YouTube space. And at that time, it was kind of, you got a lot of like content about history in America or history in Europe and stuff like that, but nothing really in Asia. So that's changed a lot now. Like a lot of people have gotten more interested in certain events and stuff like that. But I worked on that for kind of 3 years and got no traction whatsoever. But over time, kind of I started noticing a lot of, it kind of started with TSMC because TSMC is a company that has a lot of traction here. Like it's very deeply embedded in the local culture. It's even though that even back then where nobody really heard of TSMC, the company is very popular here, extremely popular. You will hear it almost spoken if you sit in the cafes across Taipei, across all Taiwan cities, you'll hear people talk about this company. And eventually got to the point where I started to kind of be really just like, why do I keep hearing this term over and over again? And that's kind of, and I wanted to share that with kind of the channel and with everyone who kind of watched my very small audience at the time. And it's been growing ever since. It's kind of crazy.
Yeah, so at least my gateway into your channel was mainly tech, but I did notice lots of, for example, videos on history, Asian history, things like this. So yeah, I wondered what the history of it was. Now, as I recall, you just said you went to Taiwan originally because you had a job offer, but now it seems like, are you doing the channel full time now, or do you still have a day job?
Yeah, I still have a day job because I'm here on a visa. So I work on the channel basically when after work and before work. So I get up 5 or 6 a.m., work until 8 or 9, and then head into the office, work a normal 8-hour day, and then come home and work until 10. And then on weekends,
Wow.
like right now, yeah, I have a little co-working space and I work all day there.
Wow. Well, I appreciate you taking some time to chat with me. I hope I can steer some viewers or readers to your content.
No, no, I love listening to your podcast, and I don't. It feels weird to be featured alongside like PhDs and professors and really, really smart people. And, it's just me. So you probably have to edit all of my dumb history life, but you know, I'm excited.
No, I love it. I think that's the colorful stuff that I think helps listeners understand you better. I want to say, I want to compliment you because the areas that you're exploring, like, okay, what's the deep history of ASML or what's the history of TSMC? These are topics that are underexplored. Where else could I get similar content? Let me just say this. When I found your content, the other place where I would find kind of related content would be, okay, maybe some tech journalism, but that wouldn't necessarily be particularly deep or insightful. It could be, but it isn't necessarily. And the other thing would be investment analysts. But the investment analysts were always looking at very specific things like, okay,
Mm,
what's next quarter going to look like, et cetera, et cetera. Almost nobody would look at, well, the big break was when they finally were able to license this key patent from Hitachi or something like this.
mm.
That's the kind of thing that you're interested in. You're interested in the actual history of these companies. And, in the modern world, these companies are, as you were just saying, in a sense, the Taiwan economy is TSMC, right?
Mm.
And so it's fully deserving of a whole team of academic scholars trying to understand what the hell happened with TSMC and Foxconn and all these companies, which helped drive the history of Asia, broadly speaking. So anyway, I think it's deserving of serious attention. You're one of the few people who's actually giving it that attention.
Yeah. I think like I came from an investment background. So I found myself reading how hedge fund managers love to say they love to read the 10Ks, annual reports, or read them all day and stuff like that. The fact is, I found that I wasn't interested in that. I wasn't interested in like the valuation part. I wasn't interested in talking about multiples and all that. I was interested in when they do something called an initiation report. So when a investment bank starts like a coverage on a particular company, they'll write this long report about the history of the company. And I found that part really interesting. I wasn't interested in the valuation part. I didn't really care about the stock price because the stock price, none of them really hit the targets anyways, or the targets are way off. So like that part of the story was something I was really interested in. I thought to myself, how about a 20-minute video, but that? And that's kind of how a lot of this stuff got started. So it's really interesting you talk about kind of this critical points in Asian companies' history, because when you learn and deep dive into all these different companies, you learn a lot about that, and you learn that some of these stories have a lot of familiar echoes and some don't. And it's really interesting to find out what were these key points for certain companies. And then in the case of TSMC, for example, you hear there's the fame, like I almost feel like that founding story is kind of old now. Like everyone talks about it, about how Morris Chang had these certain ideas and stuff like that. But you really want to dive deep into kind of what happened after that, the certain ups and downs throughout that. And you learn a lot more, I feel, for academics, industrial professionals, and investment professionals as well, rather than to kind of have packaged up into this nice ribbon story. And that was really important to me, to get those details and get them right and mix that in with the technical part, because you can't really talk about technology without being technical, in my opinion.
Yeah. Sometimes when I'm listening to one of your segments, I'm thinking, how does he know that? Like, where exactly do you get that information? That's really interesting. I feel that someone like you, who is both on the investment advisory side of things or analysis side of things, and tried to start a company as a founder or a startup guy, you really get the point that every company has its own unique history and its own unique inflection points and personalities. And it's every company is a kind of interesting story, potentially, if you look into it.
Yeah. Yeah. And, none of them are the same. Like some are more interesting than others. Like there are a couple of Taiwanese companies I've done videos on that are billion-dollar companies. Nobody's heard of them. And that's because they've had like the most boring founding story ever. But like, I'm sure it'll be interesting to some guy who invests in them. But like the learning that part is really special. Yeah.
Well, the companies that we're going to talk about have huge impacts on global supply chains and potentially even geopolitics, as we'll discuss. Now, I had to choose specifically the semiconductor industry because you actually cover lots of things. I chose the semiconductor industry because I think that's one of the main areas of U.S. China competition. Oh, let me say this. I have two goals for my listeners from this podcast. One is to get some introduction to the complexity of the semiconductor industry, because most people, I bought a laptop. Oh, is it fast? Yeah, it seems fast. Gee, your car has a lot of chips in it. I guess so. I don't really see them, but I have an LCD panel on my dashboard now. So people to them, it's just part of the fabric of their lives. They don't really understand the incredible R&D and CapEx that went into building this highly developed IT world that we live in. So I would just like to give people a sense of how rich it is and how the different subsectors of the semiconductor ecosystem, interact and things like this. And then secondly, the thing I'd really like to get into is to try to get your views on what is going to happen in terms of China trying to catch up, trying to become maybe fully independent in its semiconductor capabilities, what will happen to TSMC and Samsung and other companies, ASML, as that evolves. And maybe that last set of questions can't really fully be answered, but I'd love to just get your perspectives on that.
Sure.
So let me just start by introducing to my audience. So everybody knows what Moore's law is, right? It's the idea that every 2 years or so, maybe there's a doubling of the density of transistors on a chip. And Moore's law we could spend a whole episode talking about how Moore's law is kind of broken down recently, that maybe it's not in effect anymore, but it was in effect for about 40 years. And I believe Moore proposed it in 1965. So it's an incredible, what physicists would call phenomenological prediction. There's no deep theoretical reason why it had to be true. And since it's an emergent property of a really complex industry, it's kind of amazing that this general rule applied. My own interaction with Moore's law comes from being in and around physics departments my whole life. And even though I'm not in the area of physics that works on material science or semiconductor fabrication, none of that. I have been close to people, other professors, grad students who worked in labs doing research on things related to semiconductors. So I've sat through a lot of talks on the core technology and even on sort of meta talks about like, okay, what is the industry Moore's law roadmap and how the hell are we going to get past this? And this looks like a real bottleneck. And so I've even sat through that kind of presentation in physics departments before. So I have some insight into this. And the thing I'll say to people that I think is the number one thing that they should remember is anybody who says that we've had a tech stagnation or nothing's happened since the Apollo moon mission or some complete bullshit like that does not realize that we got a factor of 1,000,000 in compute power, mainly due to the efforts of huge armies of physicists, applied physicists, material scientists, and electrical engineers and chemists, which all kind of was under the radar, but the whole world was transformed by the work
Mm.
of these people and billions of dollars of capex and fortunes made and fortunes lost. So it's kind of this underlying driver of all the change that's happened, much of the change that's happened in technological society in the last 40 years.
Hmm.
So having said that, John, let me say that obviously the ecosystem is super complicated. We can't explore all parts of it, but I kind of want to introduce the listeners to three different aspects of the ecosystem, three different parts of it. One is fabs. And an example of that is TSMC. Maybe their biggest competitor right now is Samsung. Previously, Intel was one of the big competitors in the space, but seems to be fading. So fabs is one. Second is lithography, the actual etching of the circuit patterns onto the chip. We've mentioned this company ASML, which is in a very unique market position right now and makes a uniquely complex machine. Each of their leading edge machines sells for like 100 or $200 million. The PRC is desperately trying to catch up in that technology. So area number 2 is lithography. And then area number 3 is chip design, which is a little more of a purely cognitive activity where chip designers use very specialized software to design the chip, but then the chip is actually constructed at the fab.
Mm.
So I'd like to just have a conversation with you about those three different parts of the ecosystem. And there's still, of course, much more. There are the people that make the wafers. There's quality testing. There's all kinds of other still highly technical aspects of the industry. We have to draw the line somewhere.
Mm.
So let's talk about fabs where the physical chips are actually made. And maybe you can just give us a few sentences introducing what is the general lay of the land right now in the world.
I think like when you're talking about fabs, you're thinking really, you're just using, it's a fancy word for like factories, right? Right now you have different types of factories are out there. And with the fabs, you wanted to talk about TSMC and Samsung. They are the two big leading edge foundries out there. Intel kind of runs a different business model, though that they're trying to change that. A fab is basically a very large factory where on the inside you have this massive clean room in which you install the various parts of the equipment that will do the various parts of your wafer process, right? So when you create a wafer, that's actually done in kind of something called mask layers, where you would reproduce a pattern onto a substrate, usually like the wafer itself. Each mask layer kind of requires like steps, 15 to 20 steps. And some of the steps I think you'll be very familiar with, like lithography, but there's also deposition, diffusion, oxidation, stuff like that. So the fab is the place where that happens. And so when you have multiple mask layers, for example, N3 or 3 nanometer process node has something like 80 mask layers. And with 15 to 20 steps per mask layer, that's over 1,000 steps. You have to repeat these steps over the span until basically the wafer is done. And you have to get extremely good yield on each of those steps throughout all those processes. And not just like, oh, 80%, 90%, 98%, even 99%, it's 99.99 something something. Because you have to deliver really good yields to the customer in order to maintain them as a customer. Because if your fabless customer receives a wafer and like 3 of the dies are good out of the whole wafer, that's not very good. And you're going to drop that foundry. So fabs are not only a technical beast, they're an economic one too. A lot of people kind of really focus on the magic of the technology, UV and stuff like that. What I think is much harder to kind of bring to other people to understand is like, this is an economic system. These are highly optimized systems that kind of work between, they're at the intersection of technology, this really expensive technology, and the economics of paying for that and making sure that actually makes a profit for the customer, which is why a lot of fabs, and really key to that is scale. So like, which is why a lot of foundries, other than TSMC and maybe Samsung, they're not making a substantial profit in the industry because they don't have enough scale. They're not learning enough. They're not putting enough wafers out there to make up for the immense capital costs that you need to put in to make these make sense. Something I really enjoy about the semiconductor industry is that it's not only like leading edge technology, but it's also a story of economics and a story of business as well. So that, I think
Yeah.
that's the special part about it. Yeah.
Let me jump in and elaborate on a few of those things. So first of all, TSMC, and correct me because I'm sure I'm going to get some of these things wrong because I'm not an expert, but TSMC is an order taker. So there's no actual TSMC chip. They might make a chip for Huawei, or they used to be able to do that. They they can't anymore. They might make a chip for MediaTek or some other chip firm, but they are an order taker. They're an outsourced manufacturer.
That is correct.
Whereas both Samsung and Intel have their own chips. Like you buy an Intel Pentium processor, you buy a Samsung, I guess, Exynos chip in your Samsung phone. And I believe Samsung, though, also has some foundry activity where they'll take external orders and make chips for third-party customers. Is that true?
That is correct. I think they make chips for Qualcomm and Nvidia as well, and as well as some other customers, which we might not hear of. But yeah, they also
Right.
used to fab Apple chips before Apple moved to TSMC.
That's right. So we've got a mix here where one player, TSMC, is always just working for somebody else whose name actually goes on the chips. Samsung is a mix, and historically, at least as I understand, Intel basically just made its own Intel products.
Yeah, which is why kind of Intel starting this Foundry 2.0 process is sort of an interesting sort of world for them because they've tried it before, didn't quite work for various reasons. And prior to that, Intel and TSMC actually worked quite closely together. I think Intel was one of TSMC's major first customers. Actually, TSMC wanted Intel to be an investor. So it's sort of an interesting sort of situation for them.
But as far as the geopolitical story goes, Intel is no longer at the frontier, right? They fell out at, I don't know, it was 7 or 5 nanometer process.
I would probably say that they're still there. They're still there. I mean, when you get to this frontier, it's not really like a line. There's not like the word edge, I think, is a misnomer. You're more like, it's more like a cloud, and everyone's sort of in that cloud. There's certain companies that have decided not to kind of be at that cloud part, but like Intel's still there. I mean, like if you're still committed to trying to get to that sort of boundary, I think you're still there. There's companies that explicitly decided they're not going to be.
Understood. This gets to your economics point that, you know, if TSMC has it really dialed in, they might be at that, say, 3, 5 nanometer scale and they're making money. Whereas Intel wants to be there and maybe they have the core technical competence. They think they can get there, but at the moment they're bleeding money and they're going to have to keep bleeding money till their efficiency gets better. I mean, that could be the story, right? Something like that.
Correct.
So when I was a professor at the University of Oregon, Intel has, I think I forgot what they had. They had some fabs and design in Oregon. And then also this Korean company called Hynix
Mm,
also had some memory fabs in Oregon. So we had a master's program at the University of Oregon where physics students could get a master's in semiconductor physics or semiconductor applied physics. And then they would immediately go to work for Intel and Hynix and maybe some other places. And one of the things, again, related to a comment you made, is that I noticed in designing the curriculum for these guys, it wasn't just that they had to learn some physics, some stuff about semiconductors. There was a lot of statistical education for them because if you're running some process and you're trying to figure out, hey, this is not working, our success rate is too low, I have these 10 different parameters I can tweak. It's an incredibly complex manufacturing process. They then have to be able to figure out like what is the evidence telling me about the way I need to adjust the process in order to make it work effectively? The fab in Malaysia has this working. Why isn't it working here?
Mm.
So this sounds like a cliche, but it is a very high IQ sort of G loaded business to be
Mm.
a fab, because you need everybody up and down the line to be pretty smart, solve problems, figure things out, get things done efficiently.
Yeah.
And so it's not an easy business to break into. Like if you're an investor, you might ask, how can TSMC command such high valuations? What is it that they actually have that makes them so valuable as a company? And I think a big part of that is the experience in human capital to just run these things so that they're actually economically efficient and viable.
Yeah, that's part of the story. I think like to have the human capital, to have the knowledge, because human capital is very important. Because I think you should think these fabs of kind of like restaurants. I think I've made this kind of metaphor before. For example, a company like ASML provide ovens, capital equipment for cooking, but TSMC, Samsung, and I guess Intel, they're cooks. They're using that equipment. They're making recipes. They're learning their best recipes to create amazing food for people to see. And like a restaurant, like a fab, depends on throughput, depends on yield to some extent, right? How much dough you're using to make a finished piece of bread, that sort of idea. And if you're not doing that right, your fab loses money and your fab closes down. It's very
Yeah, I
important.
think that's a great analogy. So the fab is the restaurant where the activity happens and they actually produce the physical product that the customer wants. The lithography machine builder, which we'll get to, they make some really super expensive piece of equipment that has to be used in the kitchen, like some super oven or something. And so they're a provider of kind of infrastructure that the fab or the restaurant needs in the kitchen. And
Mhm.
the chip designers are in a way the ones who make the recipe up, right? They're like, this is how you make the souffle, and you need these ingredients, and you have to combine them in this way. So maybe that is a nice way of explaining these three components of the industry. I'd like to turn to lithography for a second. So there's this very famous company, if you're an investor at least, or if you're a technologist, it's called ASML. It's a Dutch company, and they are the sole provider, correct me if I'm wrong, of extreme ultraviolet lithography machines, which you need to get to the, I believe, 7 nanometer and below process. Is that roughly right?
Yeah. Yeah. I think 7 nanometers is capable. You can reach it without UV, but at this point, it's not commercially viable. It's not
Yeah,
economical.
right. You could do it with DUV, but it's not competitive.
Correct. Especially when you're competing against EUV itself.
Right. So now again, for the listeners, these very small feature sizes, they're not actually the feature sizes. They're actually kind of fake, but the name for the process level, say 7 nanometers, 5 nanometers, even 3 nanometers, that's very bleeding edge stuff that might go into a kind of flagship cell phone or something like this. Whereas the bulk of chips that are used, say in your car, in your refrigerator, even Internet of Things kind of devices, those are made on much coarser processes, like maybe 28 nanometers. And they're the bulk of, in numerical terms, chips made, but the big profit margins are going to be at these extremely fine feature scales where you need EUV. So ASML, their machine, which I mentioned earlier, I think it could sell for something like 100 or $200 million a shot, and they sell maybe, I think, 50 machines a year. Is that about right?
Yeah. Yeah.
These things, just to describe the extreme physics, okay, you're trying to make light in the extreme ultraviolet, so very blue, far bluer than the human eye can see, short
They're
wavelengths.
basically X-rays. It's like low power
Yes,
X-rays. Yeah.
yes, exactly. Soft X-rays. And you need that. Basically, the size of the wavelength of the light determines the smallest feature that you can reliably etch
Hmm.
on the substrate, on the chip itself. And the process, and this is an amazing, the research that went into this, I happen to know a little bit about the history of this because the U.S. Department of Energy, which is where I got a lot of research funding from DOE to do high energy physics, Department of Energy was actually involved in a big consortium to develop this technology. So they take tin, the metal tin, they take tin molecules and they superheat them with a laser until it's a plasma.
Hmm.
And there are certain transitions among the outer shell electrons of tin, which are in the right frequency range to generate
Hmm.
EUV light. And so the
Yeah.
process is unbelievable. Like you have a device where you're literally you're not just melting tin, you're ionizing a metal tin, a droplet of tin. You're capturing the EUV light that comes from that plasma. And then you're using some crazy set of super precise Zeiss, that's a German company, mirrors to focus that or to point it at your mask. And that's the way that you make these cutting edge chip designs.
Yeah.
And you could just
Yeah.
imagine it's one of the most, in a sense, complicated machines that exists on the planet, right? I mean, the set of technologies that go into making one of these ASML machines work is just incredible. And it was like a 20-year research project. You know, when it was first proposed, it was one of these like moonshot projects on a Moore's Law roadmap. And I can imagine like some wise ass theorists like me saying, "You're never going to get that to work. How the hell can you possibly get that to work? That's going to use as much energy as a small city, right?
Mm.
Just to make that tin plasma, you know." So all kinds of difficulties like that, and who knows, maybe they started thinking about being able to do this like in the 90s.
Mm.
And only now it's become feasible. So I just, back to my earlier comments, I think people just totally misunderstand and underestimate the difficulty it takes to keep Moore's law going or to keep technological progress going. Because if you're not involved in it, you're not aware of it.
Yeah. And I think like the key point with like the EUV was that you wanted to continue for the first, I would think, 40 years of kind of how the roadmap of lithography is. Because lithography was driving the concept that like you could etch smaller feature sizes. And you use kind of this very simple mercury lamp, and then you progress to eye line, which is another type of light, and then lasers, right? Your krypton lasers, your argon lasers. EUV would supposed to be the next sort of step towards that. Like you would supposed to go from like argon fluoride to EUV. However, what happened was that they couldn't get enough power out, right? So that's what you're talking about with the amount of light. They wasn't getting a good enough ratio for the light that they're putting in. The physics was always there. They always knew it could be used, but the problem was that they couldn't make it work in a way that was economical, like commercially viable. Again, there was the point about the commercial part, right? You could conceivably use this machine, but if you're not getting your money's worth, if you're not getting a strong enough light, then it's not commercially viable against the alternative, your DUV alternative, right?
Yep, that's exactly right. I mean, in these lectures that I went to in the past, where they would talk about the Moore's Law roadmap, they would always have like three different technologies that,
Yep.
okay, one of these we're going to get working, and that's how we're going to stay on this curve. And the other two, you know, after many, many teams of physicists at universities and labs, national labs, and companies would be trying all these things, one of them might work. And that's how the field kept going. Every time it was a miracle. And I remember when
Yeah.
I first heard them saying, "Yeah, we're going to be using X-rays." I'm like, "What? You're going to be using X-rays to make microchip?" You know, and if you just do some back of the envelope calculation of efficiency, you're like, "Yeah, this is going to cost as much energy as like a small city to run your fab, right?"
Yeah.
And so, but they're able to do it. They keep doing it. Now, ASML has basically a kind of monopoly right now, right? For all the fabs. I mean, they have a limited number of customers because they have to be people that want to manufacture really bleeding edge chips, but they kind of have a stranglehold. Just say a little bit about what the situation is about PRC companies, Chinese companies on the mainland trying to get their hands on ASML machines.
I think like ASML has a monopoly on working EUV machines. There's another company called Gigaphoton out in Japan. I think they're trying something new using magnetic fields to generate EUV light, which is kind of fun. And it kind of reflects Japan's past legacy of semiconductor suppliers. So there has been kind of the big kerfuffle where SMIC is a company there, China's leading foundry, and they tried to acquire EUV so that they could kind of move from 10 nanometer processes to 7 nanometer processes economically. And basically that was blocked, right? I think there's been a lot of kind of discussion about like, well, ASML is a Dutch company, the Netherlands, like how can America kind of have that sort of involvement? But like you said before, America does have a very strong stake in EUV technology. They're one of the first to kind of bring that and move that forward. They invested in it. So they had a say in how that technology is being exported out there. I think there are competitors to lithography to try to kind of catch up in that space. There's SMEE is the kind of their leader, their commercial state-backed leader. I would probably say that so far as we understand is like these products, they technically work, science works, but it's not commercially viable in the market. So unless something horrendous happens where like they're not allowed to use ASML, DUV products or something, or even like prior older generation DUV products from ASML and Canon and Nikon, because Canon and Nikon are still present in the DUV space, that SMEE doesn't seem to be able to compete in that market. But we don't really know. I mean, they make a big deal of the PR or the public relations of a certain achievement. They're really good at that. And like, I think something a lot of people need to think about when they look at a headline is that there has to be, you need to see the commercial part of that workout before
Yeah,
you're able to, yeah, go ahead.
sorry to interrupt. Yeah, the devil's in the details because I might be able to demonstrate in the lab. Oh yeah, I'm generating photons in this frequency. Everything's fine. But how reliable is that thing? And what's uptime properly integrated in an actual process that's producing chips, at the right price point that the customers will buy this stuff and there's a good margin for me. So you're right. Like that's just one step of the puzzle. Like the master of the basic physics is just the first step. And there's so many additional steps. So I think one of the things people are keenly watching is how long will it take the Chinese to catch up in across this whole gamut. Now, the government there is pouring tremendous amounts of money into trying to catch up. Sometimes they have spectacular failures where some local enterprise eats up billions of dollars and turns out to have basically done nothing and been a giant failure. On the other hand, at the academic level and in terms of their government laboratories, they have a lot of really strong scientists, especially in these areas of chemistry and physics and laser physics. All of these areas, they're quite strong. And they've been aggressively recruiting engineers from Korea, from Taiwan, from Japan for some time. So it's a very dynamic situation. And what would you say is the best source of information about how all of this is developing?
You got to you got to talk to someone in there. That's what I find. Semiconductors in general is like a very big market. And it's a market that needs to be really tightly integrated. Like people need to be working with one another. And you can make guesses based on certain understandings of how different companies work. You can make predictions, but like to see the real status of anything that goes on in the mainland is somewhat difficult because I would presume that a lot of these companies are seen as state secrets. And I think one thing you'll see big signs and big trends that I think kind of align with developmental trends in previous industries. For example, the adoption of native technologies, indigenously developed standards, stuff like that. You'll see those as kind of main points, and those you'll hear very easily. I think if you try to kind of follow it on a day-to-day basis, trying to see this thing happening or that thing happening, you're gonna get kind of lost in the details, lost in the weeds. And that's my opinion on that.
How about this angle? I hear all these stories about, now this isn't necessarily directly lithography, but say engineers with lots of fab experience, say at TSMC or something.
Hmm.
You hear all these stories about them getting recruited with huge packages to go to
Yeah,
China.
yeah.
I'm imagining there's a lot of scuttlebutt in Taiwan about that kind of thing.
I don't see a situation where, unless like someone feels like they're unhappy with the company itself, that someone's going to outbid TSMC on a salary basis. And I think like you have to understand that TSMC employs 50,000 people, and some of these people are very important, right? I would say like your R&D engineers are your R&D, your VPs of R&D and stuff like that will get paid very well. Like there are certain individuals, can actually change the way a company future fortunes are. The current SMIC co-CEO, I think, like he's an ex-TSMC guy. He was one of their stars, and then he moved to Samsung, and he helped Samsung catch up to TSMC. But for the most part, I would probably say that like hiring hardware engineers is like hiring a Google engineer. It kind of, you're getting a name, and what are you actually really getting is has to be judged on an individual basis. In terms of technology, when you talk about trends of technology transfer from Taiwan to the mainland, it's not so much of a big deal unless you need to see Chinese companies start doing something and extending on that technology themselves. Does that make sense?
Right.
It's kind of like
Yeah.
one of the key points was that when Taiwan TSMC acquired was founded, they acquired a kind of an older node, process node to work with. Then if had they just stuck to that, that would have gotten them nowhere in the global marketplace, because always they're going to get an older version, and like they need to do something more with that. They improved it on themselves with their own human capital and their own knowledge to eventually catch up to the leading edge, and then to expand beyond that. You need that sort of progress, and you need to see that stuff happen before you can take technology independence and certain industrial policies more seriously. Not to say that that the mainland is not taking it seriously, but I do sense that like it's when you have technology decisions driven by domestic politics, there is some concern there.
Yeah. It's not clear how it's going to shake out. Now, for these workhorse feature sizes or process levels, like say 28 nanometers, where is the mainland right now? At what level are they able to produce chips of that sort?
I think SMIC is doing a pretty good job. So the two leading foundries in China are SMIC, Grace Semiconductor, or I think they've changed their name now, but like those two are out in Shanghai, and they were founded by people from Taiwan, and they're actually SMIC's founder was Richard Chang, Richard Chang. He, like those companies are the leaders in the foundry space. I think, it's an interesting world there. TSMC China actually is the third leading so far as I know. So they have two fabs out in Nanjing, and I don't remember the second place, but like they were allowed to bring some high technology there, and they're competing pretty hard over there. So traditionally, I would say that for the past 8-9 years, SMIC and Grace were basically getting the stuffing kicked out of them from TSMC moving over there, because TSMC is so good at like basically wiping out a market's profit. And a lot of these companies, SMIC especially, they used Western style. Like these were companies that were founded in a time where Chinese, American, and Western relations were much friendlier. When you had transfer of technologies, adoption of these standards, and adoption of export ability, where like Western companies could commission SMIC to do chips and export them back to the United States. And at that time, SMIC was basically a labor and tax play, right? This was a company that didn't own the technologies. Like if it was a restaurant, right, they were highly reliant. Yeah. Almost like a franchise. Like, and not to say they weren't working really hard, but they're built in a way that was kind of taking advantage of a certain location, which is fine when you start. But like after a certain amount of time, certain things happened between TSMC and SMIC and all that. And then for the next couple of years, they kind of just stagnated. Now it's gotten to a time where they're becoming more important to the company or to the country's kind of technological future plans. And it's 22 nanometers is fine for a lot of people and might be fine for a certain situation. But the problem is that it's not economically, like you can't stay there forever and make a profit, because like at some point you're barely making anything. I don't know if that made sense. It's kind of like it's tough. It's an economic tough situation, because like being in the trailing edge is not where you want to be.
Yeah, that's an interesting question though. But if for strategic reasons, China just wants to be independent, in whatever that means, like not reliant on the import of semiconductors from, say, from Taiwan or from Korea, and they're just happy to maybe the return on equity or return on capital is relatively low, but they are able to produce at say 22 nanometers domestically. Is that a sufficient policy goal for them.
I'm sure that's fine. I mean, a lot of American military technologies are done with very trailing edge technologies of nodes as well. I think it's like I know Skywater, which is an American foundry, does like 180. Like that's their max, 180
Yeah.
nanometers.
I mean,
You don't.
sorry to interrupt you. I didn't mean for military, because military is like totally like way very far from the cutting edge, right? So,
Oh yeah,
but I meant like, suppose these things are going to go into refrigerators and cars and Internet of Things and even low end cell phones and things. Do they actually care that much strategically that they would actually, almost subsidize that industry, even though it isn't even the cutting edge, but they just want it. They want to be able to produce the stuff there. I don't know. I don't know what the government there has actually said explicitly about this.
I think it's tough to make a call on that because it's a commercial decision too, right? I think one of the reasons, like, you're asking a Chinese consumer to say that you want a 22 nanometer chip, but and like because you want to support your own country, and a lot of people I think will choose with their wallets and they'll choose a better product, right? Um,
Yeah. I
you're
mean,
gonna see, yeah. Go ahead.
it's what you just said. It's where a little, some people use this loose analogy between oil and semiconductors, right? Or oil and
Hmm.
chips, saying, "Oh, China imports more chips than it imports oil every year
Mm,
in dollar terms." But of course, a lot of those chips, it's embedding into a device, which then it sells right to
yeah,
somebody in Germany or Australia or something. So the whole
right.
analogy is not quite right. And then the thing is that, of course, one of the main strategic levers the US has is they could cut off oil flow to China. But the analogy of them cutting off semiconductor flow, is that even a viable analogy? Like, is that even something that could happen strategically, or that the Americans would ever actually want to do it?
It's a tough balance. I've actually was thinking about this because I wanted to do a video about, because Americans had this, actually they had this debate with the Soviet Union back in the 80s and 70s, because like the Soviet Union wanted to also establish kind of like a more thriving technology industry of their own. And the Americans debated, they had these same sort of debates where they're trying to say, well, is it right to cut these off because then maybe they'll develop indigenous capacity, or let's just deny it and make a kind of almost like a bet that the Soviet Union won't be able to catch up. It's easy to look back at it and say, oh, they made a correct bet or something. But it was a very tough balance between giving them enough technology for them to get to being open enough to meet certain requirements in the markets, to try to open up markets and trying to kind of get the Soviet policymakers to think this is important, to make it important for them, but also cut off kind of the most advanced stuff. And it's a very complicated story. I wouldn't say that there's one way or the other to do it, especially when it comes to China. I think like it's important to them for, I think right now the PRC acknowledges that they're not able to go beyond into the 7 nanometer leading edge world, and they're kind of building policy to deal with that. But does that mean that they're going to be able to develop their own capability, their own indigenous capacity? And that means that Americans should continue denying exports, or they should actually be more open. I don't know. It's hard to say. Luckily, I'm not
Well,
the person who has to decide.
yeah, let me shift from, okay, so I was focused a little bit on the issue of not the bleeding edge, say 7.5 nanometer processes, but maybe 28, where most of the chips actually are. And people who say, like, well, it's not even really a realistic risk to the Chinese that the US would try to cut off, their access to that kind of chip, because after all, like, all of those chips are basically turned into devices in China through manufacturing processes, and then that's how the
Hmm.
rest of the world gets their devices. So it doesn't even make sense that the US would want to cut that off, because then you wouldn't be able to go to Walmart and get something, right? So maybe the whole thing is just symbolic, that the Chinese want to be, they somehow maybe make a false analogy between oil and chips and say, wouldn't it be great if we were, quote, self-sufficient in chips? That's one chain of argument. But let me switch from the more commodity process scales to the bleeding edge. And let me just review how I understand the story of what happened to Huawei in the last few years. And you should
Hmm.
correct me if I get any of this wrong. But a few years ago, maybe it's longer than I think, but I think it was only 3 or 4 years ago, I got interested in Huawei I guess mainly because Trump had become president and Huawei was becoming like an issue.
Hmm.
And I don't think we'll get into 5G in this conversation, maybe only at the end. But what I had noticed was Huawei was starting to make fully competitive world-class phones. Like I think the Mate 20, Mate 30. I don't know if you're into cell phones, but Huawei had made some phones which were as good as anything Samsung was selling, and as long as you're not an iOS fanboy, was in a sense as good as any iPhone.
Hmm.
And I actually even bought a Huawei phone just to check it out, and it was using they have a design bureau within Huawei. It's called High Silicon,
Hmm. High silicon.
and the chip, the cutting edge chip, which was made I think on like a 7 nanometer process, was called a Kirin
Yep.
chip. And that was a big deal because they had designed that all within in-house at Huawei. It was, and the benchmarks and stuff, it was as good as Qualcomm and Exynos processors. And so I
Hmm.
thought, wow, this is interesting. This is a new milestone in climbing the value chain for a Chinese
Hmm.
company. And effectively, by not allowing TSMC to supply, so the getting back to the design of the chip is Huawei's, but
Hmm.
the fabbing had to be done at TSMC. And the
Hmm.
US just by fiat cut off TSMC, just said TSMC cannot supply any of these chips to
Hmm.
Huawei. Now, Huawei, around that time that I'm describing, had become close to the number one cell phone maker in the world. Actually, if you look at their just global sales, I think they were number one or number two or close to number one briefly, just for like 1 year. And then they got hammered by these sanctions.
Yep.
And so the US was able to literally destroy a huge business of a major Chinese company, a flagship Chinese company. And it had nothing to do with 5G security. This technology had nothing to do with 5G base station. It seemed to me that Huawei got on the US radar because of the 5G security threat. Like if Germany and the UK installed 5G networks all built by Huawei, the US, the NSA, and US security didn't like that.
Yeah.
The US intelligence didn't like that. Somehow Huawei got on their roadmap, but then they destroyed the consumer cell phone business of Huawei through their control of TSMC's fab. Do I have that correct?
I think there's some things that maybe we could. Yeah, yeah. I think it's on a largely whole correct. I think the thing that was key is that like high silicon and TSMC, when you're at the leading edge, you work very closely together, right? So there's a lot of trade secrets being passed over from TSMC side to Huawei side and Huawei side to TSMC side. I don't really think the United States has a vested, doesn't really care about like the like Chinese cell phones in particular. Like they like Oppo, Vivo, all these other Chinese Xiaomi, they're all kind of all around still, right? So Xiaomi at the end nearly got smacked. But like I think the key was that like what they wanted to do was remove that chip design part, that chip design portion, and to say what it is about what the Trump administration ended up deciding is that they decided to pull the trigger on that. It's a very fraught question. I think I get a lot of
Well,
very angry comments about it.
well, yeah, I mean, we could talk more broadly about Huawei. I would actually be very interested in that. But my view of this is okay, the US can have especially US intelligence services, signals intelligence services, they can have a legitimate concern that they don't want the whole rest of the world to switch to Huawei provided 5G. Okay.
hmm
They can make that argument. I don't actually completely buy their argument about the security risks. But anyway, that's a separate discussion. But even if that is their issue, what they really did was it's sort of like, like, I don't like what you're doing on the upper floor of the restaurant, so I'm going to start a fire on the lower floor. It seemed to me very egregious. They basically, by fiat, destroyed a completely different part of the company, which what that part of the company was doing really didn't have any security implications, national security implications for the United States. So
mm,
that's how I see it, but I'm curious what you think.
hmm. I reckon that like what they saw was that they didn't want high silicon to create chips that could be adopted by the rest of the world, right? Oppo, Vivo, Xiaomi, for all of that, even though they still make phones and they're very popular, they use Qualcomm chips. They use chips from Samsung or
or
whatnot, or
MediaTek or what.
yeah, MediaTek, MTK, right? So like the
But
key for yep,
sorry to interrupt you, but okay. I mean, I was following this because I mean, I went so far as even to buy a Huawei phone just to check it out. But there was never any talk of other manufacturers using Kirin chips. Kirin chips, it was a little bit like Apple and M1. It was like, these are our chips. This is going to make us number one mobile phone company in the world, or one of the top mobile phone companies. So in a way, the US kneecapped a competitor in a space which there's some strong US companies like Apple and things like this. But as far as I could tell, it didn't have any connection to national security.
it wouldn't take a lot of knowledge to get a sense that it's because to get to feel like the next step would be to export the Kirin chips, right? The fact that HiSilicon, it has its own division, the fact that this company is trying to expand it, creating all these different lines, creating Xiaopeng and all these other like different sorts of chips. I don't think it's like very hard to understand that like that's the next thing to do. And
Well,
secondly, like I think, yeah,
I think the general, I mean, I think this is certainly true. The general intent of US, the tech warriors, the people in the White House who wanted to hamstring Huawei, yes, they wanted to hurt Huawei as a company. But
yeah,
I think for people who are somewhat impartial, like if you're some guy in Spain, yeah, there were a lot of people in Europe who really like their Huawei phones and stuff, right? And you're just looking at this, what it really looks like is the US is basically trying to destroy a top Chinese company. And some of the things that company does may affect US national security, but the motivation to destroy their chip making or cell phone making business was, the only motivation for that was primarily just economic. It wasn't actually based on national security.
I think what the Trump administration eventually saw, kind of the China situations, they saw it, didn't see it as like a disparate set of like autonomously moving parts, right? They saw Huawei as like if you fund one part of Huawei, you're funding the other stuff that like is competitive.
To
That
I totally
creates
agree with you.
issues.
No, I totally agree with you. That I
Yeah,
think that's how they were thinking about it. They're like, any way we can hurt Huawei, we're going to hurt Huawei.
yeah.
But if you take a step back and you say, oh, you say to yourself three times, rules based order, free markets, what are you actually doing there? Right. I mean, you are really not operating in a very rules based order way when you do stuff like that. Right. It's like, why should TSMC not be allowed to fab chips for Huawei cell phones? By
It's
the
an
way,
unfortunate situation. Yeah,
just to close a loop on something, the base stations for 5G that Huawei makes, I believe they were using imported chips, not their own design, and on like a fairly crude, like 28 nanometer process scale. So they were not cutting edge at all, as you would expect. It's like a big blocky thing that you attach to the side of a building. So
yeah,
it's not, it doesn't have to be bleeding edge. And they have also cut off, I think, their access to those chips. That if you really wanted to cripple their ability to build 5G networks around the world, I can understand that. Like within that self-contained logic, okay, it's like, okay, let's cripple their 5G business. But I
yeah.
think if you look carefully, they crippled the cell phone business without anything like the same level of reason, national security reason, a justification as trying to attack the 5G business.
Yeah. I mean, it wouldn't take far for any American or non-American to kind of look to see situations where, for instance, like the government would violate its quote unquote principles to do a certain thing. That's not to say that I'm criticizing. I'm saying it's like, for example, Japan and the States, they competed pretty hard in the 80s and 70s over semiconductors as well. And then the United States helped end that dominance too. How's the best way to say this? Like, I'm not surprised that the United States would do that. I would
Yeah,
feel that.
I think I agree with you. I think you're saying that the US has behaved in a pretty strongly mercantilist way, using governmental power to help its companies compete
Yep.
against foreign companies many times in the past. And so you're not surprised that they did it to Huawei.
Yeah.
And
And
I
I
agree
think,
with you,
yeah.
but except that I'm sometimes in policy circles or think tank circles where people don't seem to understand this. They actually
Mhm.
they actually think that this whole Huawei story was Huawei evil. Huawei, eh, of course, there's this little inconsistency because the NSA is even more evil in a sense. Like the NSA was caught monitoring Merkel's cell phone and Macron's, and Huawei never was able to do anything like that. But anyway, Huawei bad, so we destroyed Huawei, and that's the whole story.
There's questions about like that company, and I'm not saying this to be like anti-American or that. Like I like red, white, and blue boba as much as anyone else, but I think like they saw Huawei as like a front for the military, for the PLA, and like they couldn't trace a provenance for the ownership of this company. I don't know if maybe they did see it. Maybe they looked at it and they said like, this is a commercial entity for the People's Liberation Army. And in the end, that's like, if Huawei was public and publicly owned and was like, wasn't and kind of distanced itself from the government, I feel that that would have kind of helped the situation. If you had a company that in the United States acted as like a commercial front for the United States military forces, I think that company will get heat too abroad as well.
Yeah, I mean, look, I'm as pro-American as anybody, but I think that a foreigner would look at Boeing and say, okay, well, they get these huge government military contracts. So isn't Boeing effectively subsidized by the U.S. military industrial complex? And should I therefore boycott their 737s? It's a kind of similar situation. And there might be a matter of degree here. You might say, oh, secretly Huawei is getting so much subsidy from the Chinese government that there's a mercantilist element already in its own existence. Like we can't compete. Our companies can't compete against them because they're so heavily subsidized by the Chinese government. That's kind of a separate argument, which could be correct. It's also true that many U.S. IT companies have been caught cooperating with NSA to put backdoors in so that the U.S. intelligence services can spy on foreign heads of state and business leaders and things like this. So that's a real thing. And sometimes in foreign policy, in geopolitics, it's all projection. It's like, we've been doing this for 50 years and we think you're going to do it too. So that's why we'll just point the finger at you and assume that Huawei is doing this stuff because U.S. companies have been doing this. So,
Or better yet, don't put them in a position so they are able to do it in the first place. I mean,
right.
yeah, it's a chess move. It's a chess move for sure. It's a pretty nasty
So,
one too.
yeah. So coming back to semiconductors, like in the next year or two, is there a milestone that you're on the lookout for that will tell you either A, hey, these Chinese guys are trying so hard to catch up, but this is one of the most, if not the most competitive global industries, and you just government can't just snap its fingers and make it happen. So they're failing, or these guys have their shit together and it looks like they are moving fast. Anything you're on the lookout for as a signal?
I think what would be very interesting to look at is like to say, what happens when the silicon shortage ends, right? When the chip shortage ends and the tide goes out and suddenly all these companies are building, like SMIC is building like a $3 billion fab, right? If that $3 billion fab goes online and suddenly no one wants to buy chips anymore because we're in a big recession globally, then you see kind of like how committed companies and governments are to certain policy directions, because that's when you start seeing kind of the wheat separated from the chaff. Because right now, when it's easy to make money selling any sort of chip, I mean, then that's great. Everyone can talk about all these technology things and all that. But at some point, that's going to turn. I don't see any reason why it wouldn't. And at that point, like, there's going to be companies that's going to get hurt. It's a lot easier to think about throwing 30, $50 billion at your semiconductor industry when everyone's screaming about chips. But suddenly, when everyone could get a 28 nanometer chip, well, does it make sense to put $50 billion if you're the Chinese government as opposed to like pensions or healthcare or something like that?
Yeah.
It's a tougher
I,
question.
I think I think almost every semiconductor analyst now is pointing out that, it's a cyclical industry. And so despite the shortages that we're having now, the massive investments now are definitely going to lead to overcapacity at some point. And so we'll have a bust.
It's actually kind of hard to convince people that, because I mean, the comments are very like, no, you're not, this is wrong. We're in the new world. We're in this new, like, everything's different now. AI, cloud, gaming, crypto, like that. It's hard.
That's a good sign that you're at near the peak of a bubble, is that people can't even entertain like the other hypothesis. There's sort of two aspects of this that I'm interested in, but you keep reminding me that they're interrelated because the unit economics is so important in this industry. One is the technical capability. Are the Chinese catching up in the really bleeding edge technical capability? or even not bleeding edge, but just how do you run your fab so it's efficient and things like this. But separate from that is, are they making a profit? Right. But you're sort of saying those are the same thing. Like if you're not making a profit, it doesn't matter whether you can do X, right? No one's going to pay you to do X if it costs too much, right?
Yeah, it's basically a show and pony, like a science fair project, right? It's not interesting. Like, it has no future. It's a dead end technologically.
Right. Well, it could have a future if the well, yeah. I mean, obviously, the having those engineers around and having that capability and the machines prototypes built, it can be useful if you just have to catch up and get to 3 nanometers, like it's just a crash program like the Manhattan Project. It's better to have those people around than not have those people around.
I
But
mean,
yeah,
you'll have it. Then what can you really do with it? You've made a $152,000 chip. I mean, unless it can succeed in the commercial world, I really wonder if then you're going to have a situation where they put out a press release on it. You have the propaganda kind of whip up a whole bunch of fake YouTube videos about it, and then like you're done with it.
yeah.
It's just
But
I really want to press on that because it's like you don't have an industry if there's no one to buy your stuff.
right. But okay. But I want to probe that. I agree with that point of view. But I want to probe it a little bit. So if you say this kind of stuff, you only really have the capability if you can do it in a commercially viable way, commercially competitive way. How is that related to the idea that one country can actually cut off another country from complete access to some of these products, right? So given the US has shown that predilection, right? They've literally killed like one of the flagship tech company, not completely killed, but tried to kill, almost killed one of the flagship tech companies in China by just cutting off its access to TSMC. Does that mean that even if you can't do it at completely market competitive rates, you still need to have control of that technology and be able to do it yourself, even if the government has to subsidize these companies to keep them afloat?
I guess, yeah. Like it's important to kind of know that. And I think a lot of the technology concepts are out there. So if you were a country that's opposed against the United States and or in their bad graces, then I would for sure say that like it's important to have latent knowledge and latent understanding of how to build a conceptually what would be a very advanced leading edge chip, whatever that might be. Yeah, there's no doubt that like strategically is important. Very and like there are some applications, I think, to other areas of the world. I think it's true. I think that's very true.
Do you think that the current Chinese plan vis-a-vis semiconductors is rational? Or do you think they're just overreacting? Maybe they should wait and buy all this stuff when it's cheaper, like when the bust comes or something.
Yeah, I think import substitution policies are very commonly practiced by a bunch of countries in Asia, right? Like it's a key first step towards building competency and expertise in a certain industry, right? But it doesn't always succeed. And I think like import substitution is I think China's quite good at it. They're very good at it, but it doesn't, the first 2 or 3 years is not really going to tell you if it succeeds. You need a lot more time.
Yeah, so that's an answer to my question. Maybe your answer is we're not going to know even 2 years from now, we're not quite going to know how this is all going to play out. It's still going to be uncertain. Yeah. I, I'm of two minds on when you talk about the Chinese succeeding in climbing the technology chain for semiconductors. I can sort of give arguments on both sides for why they'll succeed or why they won't succeed. On their side, they have a very deep pool of human capital and they have a very deep pool of capital, right? And very strong organizational skills when they want to get things to produce things efficiently. On the downside, this is really, in my mind, one of the most globally competitive industries. And so that makes it tougher to just flip a switch and catch up. And you have to have stamina to really keep at it for a long time, probably to catch up. And a lot of the stuff like that had to be done to get EUV working and stuff was just crazy and took 20 years. So from that perspective, it's like, okay, maybe they're nowhere close to fully catching up. So I
Yeah.
don't know. What do you think?
I think it reflects, like, I think people's thoughts on it reflects a kind of like what they think. It's a Rorschach blot of kind of showing what you really think works. In my case, I feel like the industry is the kind of the industry. It's going to be a tough uphill climb for China. They have a lot of stuff they need to do anyways. I think that the domestic market is not big enough for them to kind of really succeed there. And at the same time, it's important enough that they really care about it, and they're going to keep trying to hammer at it. And they're really good at hammering at stuff until it finally works.
But is it really just their domestic market? Because if I want a device which uses chips and I'm in Texas or I'm in Brazil, if that chip doesn't go to China, then to have the plastic built around it and then it's shipped to Brazil. If that doesn't happen, the rest of the world has to then rebuild that entire supply chain to actually manufacture the device. Okay, yes, the chip came from Taiwan or the chip came from Texas or something, but there's this whole other part of the supply chain that has to be rebuilt if you try to excise China from it. So can the world really cut China off from semiconductors? Maybe not.
I think so. I think it really depends on where the bulk of the value comes from, right? The bulk of the value right now comes from fabrication. Packaging, testing, all these other services come from different parts of the world that can be moved, right? For example, Malaysia, Indonesia, Philippines, like Intel put like packaging factories there, and then it's kind of moving them around to certain areas like Israel and stuff like that. And then when you talk about actually putting the chips into the actual electronics product, that part is simply a function of how much consumers more are willing to pay for it. Like it used to be that China had a substantial portion of the shoe making, like of shoes, right? Like shoes mostly were assembled in China. That's starting to change now. You have factories in Vietnam, Myanmar,
But
Indonesia.
but let's take the shipping. Let's take the container that holds the most bleeding edge chips, which is the mobile phone, right?
Yeah.
Isn't every single close to flagship mobile phone basically made in, well, okay, I guess I'm leaving out South Korea, but almost every leading edge mobile phone is made in China, right?
I think to kind of take what I said before about what China is like, if a government is determined enough and persists enough in the plan, I don't think anything's impossible. These companies, like Foxconn, is a Taiwanese company. I think if there is a policy that turns out to be in that sort of way, I don't doubt that anything can be done. That I don't think it will be. Also, I think it will be an economically unviable situation for both parties. I mean, nobody really wants that sort of thing to happen.
I think I was complimenting you earlier about how your segments are like mini histories of these companies and stuff like this. If I were to write a mini history of what happened to Huawei in the last 5 years, it's kind of a strange story because they got so good at 5G. They got way out ahead of everybody in 5G, which is a totally different set of technologies, like radio, millimeter wave radio technologies and stuff like this, right? They got so far out ahead of that the U.S. got afraid that they were going to build the whole next generation of, information networks in friendly countries like in Western Europe and stuff like this. And as a totally parallel effort, they also became world-class in making cell phones. And their main use of really leading edge chips was on the cell phone side, not on the 5G side. And yet they just got smacked down as a company because they were involved in 5G. But if they had been two separate companies, I don't think anybody would have cared about Kirin processors or Mate 30 Pro phones and things like that. I think it's a weird conjunction between something that the spooks really cared about a lot, the 5G networks around the world, and mobile phones, which I don't think they actually care that much about. Because I mean, they haven't knocked off Xiaomi or Oppo or anything like that.
Yeah, I think it's a weird situation, and Huawei is a weird company, and I think it's really difficult to talk about them because it's so flavored with the politics of the day. It's a tough situation. I don't think I'll ever do a video in the short term about the Huawei saga because I don't really want to get screamed at. But like, I think it's a demonstration of kind of like how maybe a state-owned company or a state-backed company can really kind of grow in a Western and competitive market. And it's also a demonstration of kind of like certain overreaches of power by a government as well.
Yeah. Yes. I think if somebody didn't already have a somewhat cynical or dark view of U.S. mercantilism, the fact that U.S. clearly practices mercantilism just like every other country.
Mhm.
Looking closely at the Huawei story, if you take off your red, white, and blue blinders, and you look at it, say you're a German looking at it or something, you can't help but conclude that they whacked this company, really deliberately whacked this company just to whack it, basically. I'm sorry, I keep repeating that. I'm being repetitive. By the way, I have a little bit of insight into Huawei because one of my postdocs, who was trained in theoretical physics, but you know, there's a lot of bleeding off of people from theoretical physics into other fields. His first job after he left working for me in my lab was at
That's cool.
Huawei's AI research center. They have a research lab for AI in Silicon Valley. So he went there and worked. He's originally from Hong Kong. And so he went and worked for Huawei for a couple of years. And now he's at, I won't say exactly where, but he's pretty senior at one of the other cell phone, the Oppo, Vivo, those companies. And he's a AI director there, but he had a pretty good inside view of what was happening in Huawei, at least for some period of time. And it's not an invincible giant or anything, but it's also not like an insidious machine of the PL. It's not an insidious arm of the PLA either. It's a company that's just
Yeah.
trying to make money.
Yeah.
So
Definitely is.
anyway, the truth is much more complex, I think, than people suspect. Yeah. So I've taken up, I think, probably way too much of your time. I think we've covered most of the things that I thought we'd set out to cover. Are there any final remarks you want to make, maybe more broadly about U.S. China tech competition or whether China is going to invade Taiwan? Anything you want to say as we close out?
First, I hope China doesn't invade Taiwan. I live here. That'd be very unpleasant. It's a tough situation. I hope it really doesn't go to that. My ideal situation is that, China and Taiwan continue to coexist with one another and continue to move towards like peace in some way from both sides. So I think that's would be really the ideal situation because I don't think anyone would want war. No one would want war. I don't think there's any contingent people who would want to have a war of that sort.
It would have really global consequences for sure.
It would have global and personal consequences.
Yeah, actually, if you don't mind
Sure.
staying on 5 more minutes, I would like to just explore this topic a little bit more, and I'm sure my listeners would be interested too. So one of the issues is because I'm much older than you are, so I don't feel like I'm in touch, even though I have extended family in Taiwan and I've spent time there. I don't really quite understand how serious the shift toward the greens is in Taiwan and toward sort of a more native Taiwanese perspective. So just for my listeners, let me explain that like the part of my family that passed through Taiwan, they were people who fled the Civil War. So when the communists won, the KMT nationalist government relocated to Taiwan. And there were a bunch of mainlanders who didn't have any connection to Taiwan, except that they fled there at the end of the Civil War in 1949. And they're actually called 49ers, that whole generation of people who went to Taiwan. They took over Taiwan. They suppressed the Chinese that were already there and this very small population of Aboriginal people that even predate the Han Chinese presence in Taiwan. And they're the ones who still effectively claim to be the true government of Greater China. And so that there's still a kind of one China policy, both officially from the Taiwanese side and from the PRC side. Now you have these younger people who grew up in a democracy. They maybe at home don't speak Mandarin. They don't speak Putonghua. They speak the Taiwanese dialect, which is a derivative of the Fujianese, I think. And they don't feel very Chinese. They don't feel like they're part of the mainland. And so this pro-independence movement, which is led by the Green Party, which is currently in power in Taiwan, has become a stronger and stronger force in Taiwan. So the question is it now basically hopeless for reunification because a strong enough majority of young Taiwanese just don't want it?
I think the basic understanding of how kind of the Green Party is, the Green Party was a pro-independence party, and it was in their charter, and it was kind of something they strove for. They got beaten really hard by the Blue Kuomintang party because of this particular issue, right? Presidential elections are voted based on the China issue. Domestic primaries are based on domestic issues. And I think the Green Party realized that they can't be pro-independence. explicitly. Like it's still in their charter and all that, but it's not something they can no longer sort of kind of call for. I think over time their views is kind of modulated to the point you don't hear it called out to this particular point, to this particular sort of
Right.
extent
They're
now.
they're less visibly pro-independence. I guess there are some real firebrand radicals in the party that still are. The president, for example.
Those people don't really understand. Yeah, they wouldn't understand. Those people should probably never get into power because they wouldn't understand. Because I think China's pretty serious about this sort of particular situation, and Americans wouldn't want it either because it's one of those situations that would trigger a war. But I think what the Green Party has done is sort of this very sort of slicing, creating a sort of like a distinct Taiwanese culture. And that's part natural and that's part encouraged by government policy. The Green Party, they're not like some sort of insidious sort of beast. They're not sort of like I feel like they're being portrayed outwardly as kind of like this kind of this power or something like that. There's just like another party trying to kind of shift policies in their own sort of way, and while supporting all these other things and doing all these other things and winning elections at the same time. I think a lot of what you see here, a lot of what I see on ground in Taiwan is that like they've accepted that there is some sort of identity separate from China, mostly amongst the younger people. The older people kind of see it as like, well, we see ourselves as Chinese, but right now what's going on in the mainland is kind of weird, so we don't really get involved with that. So it's kind of like a tacit sort of alliance between those two, if that makes sense. So that's
Yeah,
why,
no, that was great. But when you say the stuff that's weird that's going on, is that because of Hong Kong primarily or because of Xi Jinping?
yeah, there
Like it
was a period in time
Yeah.
where it really seemed like the two sides would be able to sort of find a negotiated peace. And I think it
Yes.
was very close. And I think partially because of Hong Kong, but partially because like the CPC did change, like did make a sort of a hard turn away. And who knows who started it, but it's like the CPC will have their own perspective to say that like the Taiwanese have been taking more than they can give, right? Then they give more rope, take more rope, right? So it's like it's sort of a he says, she says thing. But there was a point in time where like, it really seemed like the two could have been really tight together. There was increasing integration and there's really close sort of there was a satisfaction between the two. Things have changed a lot more, and I think it's partially because of you know Xi Jinping, COVID, Hong Kong, all that. And I think it will take some time to overcome it. But I think like it's harder to make that argument now because like it feels like the government has made a sort of explicit turn away
I
from it.
I think to me the best case scenario is probably that we have status quo for another decade, and maybe China takes a more reformist turn again, right, after Xi Jinping, whoever succeeds Xi Jinping, and then maybe at that point, China will be perhaps very developed, and there can be a kind of two-state, one state, two system kind of agreement between the two. And hopefully
Yeah, I
nobody
think
wants
that's
to go to
possible.
war. And that's to me the most optimistic thing that can happen.
Yeah.
When I was at Academia Sinica, which is this, pretty, I guess, elite science research institute in Taipei, I was on sabbatical there. This was over 10 years ago. I remember conversations with the other physicists who were very rational, smart people, but a mix of greens and blues. So greens are the pro-independent, at least somewhat pro-independence party, and the blues are the definitely not pro-independence KMT party.
Hmm.
And we used to have these pretty difficult conversations, but like I think they would not argue with each other because they knew each other personally and just had to work with each other every day. But I was a strange American guy, so that if I brought it up, they would humor me. And I used to ask the Greens, I used to say, "What's your scenario that you guys are going to escape being reunified?" Because I'm pretty sure they really want, talking about the mainland, to reunify.
Hmm.
And assuming they continue to develop economically, eventually they're going to be able to do it against your will. So I only see two possibilities. Either you do reunify at some point, you don't have a choice, or the other option is the Chinese civilization undergoes some collapse again, like the mainland, self-destructs. That's the only way you're going to escape. If the mainland doesn't self-destruct, you're not going to escape. You're going to become part of China again. And these green physicists, after I pose it that way, would say, well, there's no hole in your logic. I can't disagree with you, but I just hope emotionally that we somehow manage to be independent someday. But I said, like, would you be willing to be independent if the cost was that 1 billion people in the mainland were thrown back into savagery because of collapse of their system? Because that's the only way I see that you get out. Do you agree with me, or do you think that's crazy what I just said?
I don't really think it would need to be that extreme. I think for the most part, people are pretty happy with the status quo. And I think those people who are explicitly calling for pro-independence right now are probably the younger types who feel like they would be able to, this is the things this should be. But over time, they will gain perspective too, like the party itself. I think there's still a lot of cultural ties between the both sides. And, for the most part, the individual people seem to be quite cordial to one another. So, like, I think in the heart of it, it's just the window's not open right now. The window can open again.
Yeah. No, I agree with that. I think everybody right now just wants to kick the can down the road and not make waves. And I think that's totally the right perspective. But I guess what I was trying to emphasize is that it doesn't seem likely that the way out is that the mainlanders are going to give up on this. And if they continue to develop economically, then you're not going to have a choice.
Conducting an invasion across 100 miles of sea onto an island that is largely that's been quite militarized or fortified over 50 years is going to be difficult. This is the most I'll ever say about this because I'm no expert at all, but I think it's going to be really difficult. It's really difficult, and I don't think any military would want to try that unless they have to.
If you're interested in this topic, I could have a whole, another episode to discuss it with you. But the one thing I will say is that the ease with which the mainlanders could 100% blockade Taiwan using missiles or subs, anything, because the technologies are so advanced now. People forget how war would be different today than what they're used to. They could interdict all shipping and air travel in and out of Taiwan like it was nothing. And when you get 50% equality,
right, but then you have to consider the counter steps beyond that,
right?
Like otherwise, obviously they would have done it a long time ago. So
no.
So then what do they think is going to happen?
I mean, this is in a situation where they're the largest economy in the world, right? So this is like, what's going to happen to you if China continues to develop and their GDP reaches, say, half US per capita level. So their total GDP is twice US level. And they just say, hey, tomorrow, no ships come in and out of Kaohsiung because we have the missiles, we have the satellite coverage, we have the subs. Just there's no energy and there's no food coming into Taiwan. I'll just wait until you guys surrender.
I think I see them possibly doing a blockade, but I don't see it coming simply
No.
because
That's
they're
just
richer.
a prerequisite. Like they're going to be at a point where they can basically say to the Americans and these other guys, like, I don't really think you want to intervene in this one, and we're not going to invade them, but we're just going to cut them off, and then they're going to surrender. And I don't see a counter strategy for that. In the scenario where total Chinese GDP is twice US GDP, and they have continued to develop technologically the way that they're developing.
We'll see if that happens. I think things are a lot more complicated than that. I think there's always communications between the two sides, and the United States can get involved as well. And there also should be considerations on what it will do to whatever wealth that's owned on both sides of the strait. So I think it's a very sensitive topic.
Yeah. No, I wasn't saying that super simplistic scenario was actually going to happen. I'm just saying, just as a strategic exercise, I think they could do that if they wanted to do it, but just in terms of actual capabilities in this future scenario.
It would represent the end of lifestyles on all of us on this island, including myself. And I think it's difficult for myself to think about or kind of consider that. Yeah, it's hard to say.
But when they threaten that blockade, the piece of paper that they're going to dangle for you is like, no, it's two systems. You guys do whatever you want. I think it can be something like that, where like we grant you the autonomy that we originally granted Hong Kong or something, right? So,
I don't think
you know,
that option is so much on the table anymore right now.
yeah, I think right now, but in 10 or 20 years, people will maybe forget what happened in Hong Kong. Well, we'll see. I mean, it depends on what happens in the next 10 or 20 years in Hong Kong. But
Very true.
yeah, but just one final comment. Like when East and West Germany were reunified, I think the cultural gap between the East and West Germans was much larger than what the cultural gap is really between, I could be wrong on this, but this is just my impression, between Taiwanese and mainlanders. Like to me, they mix pretty much effortlessly.
Yeah.
And there's pretty good overlap in like the media that they consume and the things they think about and what they know about. And, you know, it doesn't seem like there's a huge gap. Now, maybe that's because mostly I'm seeing these mainlanders and Taiwanese mix in academic settings and stuff, and there just really isn't much difference. But it just seems like it wouldn't be that difficult on just purely cultural grounds to reunify.
There's differences in terms of kind of like, snobbishness and stuff like that. But I wouldn't say that, yeah,
Yes.
it's not I would say the differences are quite subtle.
Yeah.
Dialect, values. I think it's maybe nice to say is like Taiwan is like China's Canada. They're quite nice.
Yep.
Um,
Yep.
Meanwhile, the mainlanders are a bit more aggressive, a little more,
Blunt.
yeah, a little more blunt. It's a different, but yeah, they're cordial with each other and like they speak the same language. So it's like they're always going to be, I think personally, like they're kind to each other. Like, but politics is always complicated with the way things are. And on both sides, I think both sides don't really like their own politics to some extent.
Yeah. No, I mean, another solution would be the mainlanders do so well that they just forget about Taiwan. They're like, what do we care? Let these guys be independent. Like, why is this an existential thing for us? Let them be, because we're already so successful on our own. That would be a great outcome too, right? I would love that. I would love it if that just happened.
That's unlikely, but yeah, that would be very nice as well. But I would say it's also just like, just they continue to hold the claim and they could also just like, they got other stuff. They got bigger fish to fry right now, right? Like they got other things they need to do. And at some point, like you can still hold the claim, but you have other things you need to deal with. And especially considering that Taiwan is literally, as a population, is smaller than Beijing. I think China's got other things they really need to focus on right now.
Yeah, I totally agree. I sometimes wonder why. I think it must be some internal domestic politics thing where hardliners just won't let it happen. But if you were a little bit more of a reformist leader in the PRC government, I can just see you wanting to just throw all the propaganda in reverse and just say, oh, Taiwan, who needs it anymore? They're such lovely people. We should just let them have their own experiment in their own government. Like just throw the propaganda in reverse. And then maybe then it won't be a big deal. And everyone will just forget about Taiwan. But I think the hardliners wouldn't let you do it.
Probably.
Yeah.
And it's also, I do think that does misunderstand how deeply inculcated this sort of stuff is. It drives back to the 100 years of humiliation, drives back to all that other stuff, imperial interlude. So it's like imperial intervention. So I think it's going to be really hard to tear that out. But I do think it might be simpler to simply just let it
Yeah.
stand.
No, for now, for sure. Yes, that's the best solution. The reason I said to these green physicists that I just don't think the mainlanders are going to forget about it. And if they continue to get stronger, then you're not going to have a choice. That was my primary assumption, was that it is so embedded in the 100 years of humiliation, and it is still an unrecovered part of China, right? So that's my baseline, I think.
All right. Well,
So,
yeah.
great. Hey, I've taken way too much of your time. I really appreciate it. If we ever meet in person, I'm going to buy you multiple drinks.
Are you going to edit 2 hours of podcast? That's crazy.
Well, maybe I'm going the Joe Rogan route. We'll see. Maybe we'll edit it down if it's too boring. But I thought it was great.
Sounds good. Fantastic.
All right.
Thank you.
Take care, John.
Take care.